Hello, everyone. Today I will be discussing about the properties of dental materials. In order to understand the performance presented by the materials, we should be familiarized with some concepts. First, we will look at the mechanical properties. Before we dwell deep into the topic, we should have a clear idea about stress-strain and its relationship because the mechanical properties of a material is expressed in terms of stress and strain. Okay, so basically, stress is nothing but an internal force developed in response to an external force acted on the particular material. This internal resistance formed will be equal in magnitude and opposite in direction to the applied external force. Let's take a 3-unit FPD, for example. The external force will be the masticatory load, and in response to it, an internal resistance equal in magnitude and opposite in direction will be developed. Depending on the type of forces involved, the stresses can be of compressive, tensile, shear, and flexural stress. Compressive stress is the internal resistance developed in response to a compressive force, which is nothing but two axial sets of force applied to an object directed towards each other in a straight line. In the same way, tensile stress arises due to tensile force, which has two sets of forces directed away from each other in a straight line. The tensile force tries to stretch the object or elongate it in simple terms. Shear stress is produced by the twisting or torsional action on the material. The stress developed resists the sliding or twisting of the one portion of the material over another. Flexural stresses are produced by the bending forces, and it can happen in two ways. First one occurs when flexural force is applied on a structure to three-point loading, whereby the end points are fixed. Here in this case, the force will be applied in between the end points. Compressive force will be developed in the concave side, and tensile stress will be developed on the convex side. Now let's compare the example with a 3-unit FPD. Here, the compressive stress develops on the occlusal side, and tensile stress develops on the tissue side. The second type is seen on a cantilevered structure when subjected to a load along any part of the unsupported end. Here, the structure tends to bend towards the tissue side, so the occlusal region becomes more convexed and kind of stretched. I have previously mentioned that tensile stress will be developed in the convex region. So in this case, tensile stress on occlusal side and compressive stress on tissue side. Thank you for watching. In the next video, I will be covering strain and stress-strain graph. Stay tuned.